What is a black hole, and what if you fell in? Theories and facts. Black holes are some of the strangest, most intriguing structures in outer space. They are incredibly dense, with such a strong gravitational pull. Even light cannot escape their grip if it comes close enough. Black holes are only observable when they feed on stars or gas clouds that wander too close to their boundary, called the event horizon. Beyond the event horizon lies a tiny point called a singularity, where gravity is so strong that it infinitely curves space-time itself. As we know them, the laws of physics break down, implying that all hypotheses of what lies beyond are mere speculation. Welcome to Brainbender Solarium. Join us as we travel through space and explore some interesting facts about theories on black holes. Albert Einstein described black holes for the first time in 1916 with his general theory of relativity. The word black hole was coined by the American astronomer John Wheeler several decades later in 1967. After decades of black holes being recognized only as theoretical entities, the first physical black hole was discovered in 1971. Then, in 2019, the Event Horizon Telescope, or EHT, collaboration published a black hole's first ever documented image. The EHT saw a black hole in the middle of the M87 galaxy, whereas the telescope was focusing on the event horizon, or the region past, where nothing could escape the black hole. The picture maps the rapid loss of photons, particles of light. It also opens up a whole new research field into black holes because astronomers now understand what a black hole looks like. Astronomers have found three types of black holes: stellar black holes, supermassive black holes, and intermediate black holes. Black holes also have different proficiency levels, such as rotation or electrical charge. So if you fell into one, your fate might depend on what kind of black hole you choose. Let's talk about black stellar mass holes. These holes form when very large stars burn up their fuel and crash into themselves. Stellar mass black holes may be a feeble relative to their larger cousins, but they possess more intense tidal forces outside their event horizons. This variance is due to a black hole property that is surprising to most. Smaller black holes have a more drastic gravitational gradient than supermassive ones. There is a very large gravitational shift within a very short distance. So, if we fell through a stellar mass black hole, we probably wouldn't care much about the mysteries we might be able to reveal on the other side. We might be dead hundreds of miles before we reach the singularity. This scenario is not solely based on theory and speculation. Unlike falling into a stellar mass black hole, our understanding of falling into a supermassive or intermediate mass black hole leads us to believe it will be slightly less of a nightmare. Although death would still be your destiny, you might be able to make it to the event horizon and continue to fall within the singularity while still alive. In this situation, you can see out into the surrounding space, at least in theory. But no one will be able to find you until you've passed the event horizon. And if you were carrying a torch and struggling to beam it out, the light would slip back into the singularity with you. It does not matter what kind of black hole you fall into, you are eventually going to get ripped apart by intense gravitational forces. Given that it is possible, though unlikely, that if humans live long enough to be the forerunners of advanced space travel technology, we may be able to explore a black hole close up. We might even throw a few probes into the black hole to see what happens if we do. Sadly, since nothing can escape the horizon of the case, not even data, we will never be able to know for certain what happens when the matter reaches the point of no return. So even if we get a chance to take a cosmic cliff plunge into a black hole, we should probably avoid the temptation. Black holes are very strange entities. If we fall into a black hole, the long-standing scientific theory states that gravity would stretch us out like spaghetti, but our death would come before we entered singularity. A 2012 research study published in the journal Nature indicated that quantum effects would cause the event horizon to behave much like a wall of fire that would immediately burn us to death. Another strange fact about black holes is that these holes don't suck. Suction is triggered by yanking something into a vacuum, something a black hole is not. Despite that, artifacts fall into them just as they fall into anything else that has gravity, much like Earth's gravity holds you to the ground. The first celestial object to be called a black hole was Cygnus X1. Cygnus X1 was the topic of a friendly wager between Stephen Hawking and fellow physicist Kip Thorne in 1974. Hawking wagered that the source was not a black hole, but Hawking conceded defeat in 1990. Miniature black holes might have progressed right after the Big Bang. Rapidly expanding space may have pushed certain regions into small dark black holes smaller than the Sun. Interestingly, if a star moves too close to a black hole, the star breaks apart. Astronomers believe that the Milky Way has anywhere from 10 million to 1 billion stellar black holes with masses as large as 3 times the Sun's size. Black holes remain a terrific feedstuff for science fiction books and movies. You might have seen the film Interstellar, which relied heavily on Thorne's incorporation of science. Thorne's work with the film's special effects team led scientists to better understand how distant stars could look when viewed near a fast-spinning black hole. Black holes remain one of the universe's great mysteries. While we have learned a lot about them, there is still much we don't, and current technology won't allow us to find out. For now at least, they are portals to the unknown, left to the imagination and the constructs of science fiction. Thanks for joining us. We hope you found this video interesting. If so, take a look at some of our other videos you see on the screen now. Also, ring that bell to keep up with new content that we publish weekly. We'll see you next time, here on Solarium.